Good evening. My name is Dheeraj, and today I'm going to present Housing Visual Analytics Project 2. So here in this project, we use PCA, MDS, and scatterplot matrices, as well as downsampling with the help of stratified and random sampling to visualize housing analytics data and hopefully find some interesting observations. So first, to start the project, we use the command python app.py to set the project up, and now as you can see it's starting up in the local server. Now we go there, so we go there, and as you can see here, it opens up directly with the scree plot of the housing analytics data. In total, as you can see here, there are 14 components, but the first component is approximately 55%, uh, explains 55% variance, as the second component explains around 10%, third component around 8%, and so on. And as you can see here, the intrinsic dimensionality of this data is around four components, and this is for stratified sample data. Uh, so I will explain first how I stratified sample the data. So initially I first used k-means on, and from this k-means I found the optimal number of clusters using the elbow method, and it was around 3 or 4. So, and from those 3 clusters I sampled the data evenly by taking 25% from each cluster, so that I get 25% of the whole. As such, I got the stratified sample data, and now applied PCA on top of it to find the PCA components and also the PCA eigenvalues. So the y-axis is eigenvalues, and I converted them into percentages to explain the variance, and the x-axis is the principal components. And this is for the stratified sample data, and you can see that for the original data it's a little different, but it's almost the same. So it's a little bit different but almost the same. And for randomly sampled data, it's also a little bit different but almost the same. And the bias introduced due to the sampling is quite less, and that's good here because we can actually use this stratified sample data in data heavy projects. And this is only for scree plots. Now if you want to go to the PCA plots, you can click here the 3 buttons. So now we can go to the PCA plots, and as you can see here, this is for the stratified PCA scatter plot. For the stratified data, I have plotted the principal components, taken the top two principal components and plotted a 2D scatter plot. And the same thing for the original data. uh, the same top two principal components, and plotted them. And this is for the random data. So from this we can see that this is shape the houses are clustered around these two areas. So as you can see, the density, basically the density of houses or more. And upon further investigation, I found out that the houses here are the low price houses or the poor area houses, and the houses here are much richer, and the houses here are owned by families. Now coming to the this is for the PCA plots, and coming to the MDS plots, we have a total of 6 MDS plots. 3 of them using the Euclidean distance and 3 of them using the correlation metric. So what I found was the correlation metric, the plots are the plots are more evenly distributed. The points are more evenly distributed. So from the center, so every point as it is expected. And this is for the stratified data, and this is basically the MDS scatter plot using Euclidean distance, original MDS scatter plot. And then this is the MDS scatter plot for random MDS scatter plot for the Euclidean distance metric, and this is the stratified MDS scatter plot for the Euclidean metric. Now we have seen MDS scree plots and all. Now we can go for the scatter plot matrix. So to first, before doing scatter plot matrix, I uh, first found out for each data. I found out which of the attributes are the most loaded value, most loaded, contains the highest PCA loads. So as you can see from here, for the original data set, the year remodeled, when the house was remodeled, and the number of zoning components in the house, and also the BSQ number of the house are very important. Basically, these three are the highest loaded PCA attributes for the original data set. And for the randomly sampled data set, this is a little bit of difference, but the 2 out of 3 are same for the original data set and the random data set. And same here, the stratified sample data set, the orderings are a little bit different, but the 2 out of 3 are same. So there's not much effect here, but this is a little bit of difference in the data, how they're ordered and which components are important for different kinds of samplings. And you can find all the loadings in the report. And from these loadings, I took the data and then plotted a scatter plot matrix, as you can see here, for stratified data, random data, and original data. And overall, what I found out was doing PCA matrix and MDS matrix really helped in understanding the data much better, and we can really use PCA plots to reduce dimensionality and then go for modeling. And also MDS really helps in understanding the correlations between the data better, and also it helps in maintaining the similarity between points even though the data is downsampled or reduced in dimensionality. Thank you.